So in my last video, I made an interface module for an ILDA compatible laser projector. And I asked that if I had enough interest, I would turn it into a real module. Well, I had enough interest, and I'm also told that it's pronounced ILDA, not Lida. Dope. This will be the build video for those of you that want a kit. Of course, I'll put a few of these modules together for those of you who want one, but have no desire to build it from a kit. Note that this kit will not include a DB25 cable. One similar to this with one male end and one female end will be required to connect this module to a laser projector. These are readily available from the usual sources. An instruction sheet will be provided with each kit. Alright, let's get to it. I like doing all the surface mount parts first, as access is better before all the through-hole parts are installed. The first part will be the 100 ohm resistors on top of the PCB. These parts are highlighted here. I solder surface mount by placing a dab of solder on the pad, heating it up, sliding the part into place, then soldering the other pad. With all the 100 ohm resistors in place, it should look like this. Next are the two 1 kilo ohm resistors on top of the PCB, and here they are installed. All the other surface mount parts on the top are 100 kilo ohm resistors, and look like this installed. Now flip the board over and do the surface mount parts on the back side, starting with the TL074 chips. These chips all have the same orientation, with pin 1 towards the top of the PCB. And installed. Onto the resistors, starting with the two 10 kilo ohm resistors here. Next are the two 47 kilo ohm resistors here. All the remaining resistors on the bottom side are 100 kilo ohm and look like this installed. The final surface mount parts in the back side are 100 nanofarad capacitors highlighted here and installed here. With the hard part over, onto the through-hole components. Starting with the 10 microfarad capacitors. Note that the positive side is marked on the PCB with the plus symbol, and installed. Next are the 1N4148 signal diodes here. Then all the remaining diodes on this side of the board are 5.1 volt Zener diodes, highlighted here, and installed. The final part on the underside of the PCB is the power connector here. Flipping the board back over to the top side, the first through-hole component are the two 1N4007 diodes. Note that on the silkscreen for the D10 is backwards on the version 1.0 PCBs. The band of the diode should be pointed towards the top of the PCB like this. I've retouched all the PCBs included with the kits with a paint pen. I fixed this in my personal build off camera. Now for the potentiometers. Starting with the 100K potentiometers. Note that stem length of the pots in your kit may vary. Next, 10K pots. Then the 2-gang 10K pot at the top of the PCB here. Jacks and switches are next. Set don't solder these parts onto the PCB. Then set the faceplate down on top of them and attach the switches and jacks with their corresponding nut. Then flip the whole assembly over and solder. This way the alignment of the jacks and switches with the PCB and faceplate can be assured. The last soldered piece is the DB25 connector. Only 9 connections are needed to be made to the PCB. To make these connections, take some of the off-cut legs from the diodes used in the previous steps and solder them to pins 1, 2, 4, 5, 6, 7, 13, 17, and 25, trying to keep them as straight as possible. Then trim the legs to the same length. Give yourself plenty of length to poke through the PCB. Set the DB25 on the faceplate and verify the legs are coming through the holes highlighted here. Before soldering, attach the DB25 with the standoffs and nuts. A 3/16 socket helps to tighten it down. Now solder and trim the legs to the final length. The final step is to add the knobs, and you're done. I highly recommend connecting this module to a current limiting power supply for testing before adding it to your rack. Be sure to attach it to your rack with all 4 screws. The DB25 cable can really wag the dog. And there you have it, a build of an ILDA laser interface module. Hope you all enjoyed, thanks for watching, and I'll see you next time.